So we are now going to talk about confidence intervals of difference. This corresponds to 10.4 in the notes, okay? We are given two sets of data. For YA, we have NA number of points, and for YB, we have NB number of points. From YA, we know that we have YA bar, okay? YA bar is the average of YA, and we also have YB bar. YB bar is just the average of YB. So these are the two sets. You have this bunch of things. So you believe YA actually coming from a normal random distribution with mu A, sigma A, okay? And you believe YB are also another random variable with normal distribution mu B, sigma B. So we have two distributions. Now you want to find the difference. What's the difference? You want to look at mu A and mu B. So suppose these are what? The number of bus passenger in a bus in a certain specific time. And YA is bus A and YB is bus B. So let's say these are bus. So if equal, you are meaning that these two bus routes, they have the same number of passenger at a time. And if they are not the same, that means what? That means they have different number of passenger in the bus. Different bus have different number of passenger, and some bus has more people and therefore more crowded. So you make the argument that that bus need more resources, something like that. And we are now going to use confidence interval to make this argument. We are going to study, is this true? So how do we study? So we will study mu A minus mu B. So first, we call that we have Y bar A. And if all these Y1, Y2 up to YA are all distributed like this, with the mu A sigma A squared, then by theorem, we know that Y bar A will also be a normal distribution. But same mean, but the variance will be divided by NA. And Y bar B will be also a normal distribution, but variance, same average, same expected value, but the variance will be divided by NB. Then what? What if I consider Y bar A minus Y bar B? If I consider Y bar A minus Y bar B, this is what? A normal random variable plus a negative normal random variable. It will be a normal random variable. Now the question is, what is this question mark? So what's this question mark? So what is this? This is the expected value of two random variables. By what? By expectation is linear. This question mark will be just the sum of mu A and mu B. But here, we are considering subtraction. We are considering subtraction. So this question mark will be the subtraction between mu A and mu B. So we will have this. Then what about here? This is the quadratic formula of variance. And if A is 1 and B is -1, this equation still satisfies. If A is 1 and B is -1, what we have? We have Vx minus y equal to what? 1 squared, so Vx plus B squared. B is -1, but -1 squared is still 1, so plus Vy. So the subtraction of the two random variable, take the variance, will be just the sum of the variance. So now we have one random variable, another random variable. This one, the variance is this term. This one, the variance is this term. So what will be this question mark? It will be this number plus this number. So now we call that if x is mu sigma square, then x minus mu divided by square root of sigma square, that means divided by sigma, will be 0 and 1. Okay, so this implies this. Okay, then now we replace this thing with this thing. Mu here is this thing. Sigma square here is this thing. So we are going to do the standardization, get the 0-1 standard deviation, which will give us what? It will give us, okay, and divide by square root of this thing. This will be what? A 0-1 random variable. Then what? The confidence interval will be, so the confidence interval for this will be this thing. The 95% confidence interval, if mu A minus mu B is under the normal distribution, then the 95% confidence interval will be like this.